Hello, class. This is the fourth video covering activity 5.1. So far, we've found the domain of a rational function. We found the vertical intercept and the horizontal intercept. And now I'd like to explore the equation for the vertical asymptote. What's nice about this is we've already done the heavy lifting. By finding the domain of a rational function, we actually know the equation of the vertical asymptote. So when I look at this 2x plus 12 divided by x minus 4, we found the domain to be all real numbers except x equals 4. Right, and if you recall, I worked these out on separate paper, right? So the domain was all real numbers except x equals 4. So the equation of the vertical asymptote is actually the exception to the domain. Right, the vertical asymptote is a vertical line that the graph of a function gets closer and closer to, but will never actually touch. So the equation, right, if I were to ask you, what is the equation of the vertical asymptote for this function? It's the exception to the domain, which in this case was x equals 4. If we were to graph 2x plus 12 divided by x minus 4, all right, and I changed my window, I made it a little bit bigger, negative 15 to 15, and negative 15 to 15 for the y min and y max. When I graph, you'll notice there would be an imaginary dotted line. Again, some of your calculators will draw a solid line here, but at 1, 2, 3, 4, at x equals 4, you'll notice there's an imaginary line that my graph will never touch, and that's the equation of the vertical asymptote. And when I look at the domain for the second function, 1 over x squared plus 7x plus 12, the domain was all real numbers except x equals negative 3 and x equals negative 4. So the equation of the vertical asymptote will actually be x equals negative 3, x equals negative 4. So I guess what I'm trying to say is if you can get the correct domain, you will find the correct vertical asymptote, because the vertical asymptote is simply the exception to the domain. So here I ask, what is the equation of the vertical asymptote? The vertical asymptotes occur at x equals negative 3 and x equals negative 4. And I want to graph this function just to see, do I have a break that occurs at negative 3 and negative 4? So I enter the function into my equation. Notice how I use parentheses for the denominator. I press graph. And as you would expect, at negative 1, 2, 3, there's a break, and at negative 1, 2, 3, 4, there's a break. And that break, or those imaginary dotted lines, occur at x equals negative 3 and negative 4. And I can actually zoom in on my graph. There's a button called zoom, and if you look at number 1, it says box. I press number 1. I'm going to draw a box. Right, so see how I'm pressing the down arrow? I can set the corner of my box. Right, so I move my cursor somewhere down here in the, I guess, fourth quadrant. I press enter. And now, as I start to press the arrow keys, you can see I'm starting to form a box, and my calculator will zoom in on this box. Okay? All right, so here's my box. I press enter, and it's going to redraw. I did that just because I really wanted to zoom in on x equals negative 3 and x equals negative 4. Right, so here's 0, 1, 2, 3. And you notice I can draw an imaginary dotted line through x equals negative 3, and the blue line will never touch. And at negative 4, there's another imaginary dotted line. And those imaginary dotted lines really are represented by this x equals negative 3 and x equals negative 4. They symbolize the vertical asymptotes. Okay, and then the last two. This x squared minus 8x plus 12 over x cubed minus x. Well, remember, when I asked for the domain, we said the domain was all real numbers except x equals 0, x equals 1, and x equals negative 1. So the vertical asymptotes will actually be x equals 0, x equals 1, and x equals negative 1. Okay, so what are the equations for the vertical asymptotes? Here they are, 0, 1, negative 1. If I were to graph this function, I'd have imaginary dotted lines at x equals 0, 1, and negative 1. And then the last function, The domain for this x squared over 5 was all real numbers. So the equation of the vertical asymptote, well, there are no vertical asymptotes. If there are no exceptions to the domain, then there are no vertical asymptotes. You see, the other three functions, there was an exception to the domain at x equals 4, there was an exception to the domain at x equals -3 and x equals -4, and so on. This last one, this x squared, is simply a parabola that's really wide. So since there are no exceptions to the domain, there are no vertical asymptotes. Thank you for watching.